Okay, guys, let's talk about the next topic, which is vector projections. I am going to make one little video about what is a vector projection so that you can have a good concept of what it actually is. In the next video, we'll do a couple examples of how do you actually calculate one. Okay, so if you don't care about understanding the concept, you just want to learn how to do the problems, you can skip to the next video. But if I were you, I'd watch this video because it'll give you a purpose and an understanding of the problems that you're actually doing. Okay. So what is a vector projection? A vector projection is when you take one vector and project it onto another to figure out how much of this vector is helping the other vector. Okay? You think of the word projector, you think of like a video projector, right? It takes a picture and projects it onto a wall. In much of the same way, a vector projection takes a vector and projects it onto another vector. So let's take two vectors. Let's take vector A and let's take vector B. Okay, just two different vectors, different directions. Okay, and we're going to figure out what is the projection of vector B onto vector A. So that's the notation for that. Vector B is being projected onto vector A. A is in the subscript there. Okay, so in this case, A is like the wall or whatever you're projecting your picture onto. Okay, so A is like the wall that your projector screen is on. B is like the picture that's being projected onto the wall. Okay, so our projector is like up here, and it is shining light directly at a 90-degree angle onto vector A. And if all these rays of light are at 90 degrees to vector A, what's going to happen? There's going to be a shadow directly below vector B. This will be the shadow of vector B, right? So if you shined a light at 90 degrees to the wall A, you'd end up with this shadow that lines up with A. Okay? The shadow that vector B makes on A, that's this vector, projection of B onto A. That's what this is, proj A of B. Okay? That's what that vector is. So this, you could think of this as how much of B is in the direction of A, and the rest is perpendicular to A. So I could take the projection of B onto A, and I could add this other vector that's 90 degrees to A, and add those two vectors together, and you would get vector B. Okay? So that's the projection of B onto A. You could think of it as the shadow of a vector onto the other vector at a 90-degree angle. Okay? How is this useful? I'll show you a quick reason that this is useful. It's helpful. If you're in physics, you probably know that you can use it to find force, components of force vectors that are helping objects move in certain directions. So the classic example is suppose you've got a ramp. Okay, that ramp can be represented as a vector, and you can figure out the direction to that ramp. If you get the rise and run, you can figure out the x and the y components. Suppose this thing runs 20 feet and rises 10 feet. Okay, so that's the vector of your ramp. And suppose you're pushing a box up that ramp into a truck or something. Okay, and suppose that you're pushing this box directly in the horizontal direction because maybe you're too short and you are pushing this box horizontally. You can't push it in the direction of the ramp, but you can push it horizontally. Well, you guys know that even if you're not pushing the box directly up the ramp, it's still probably going to slide up the ramp, right? But it's not the most efficient way to apply force. You probably should try to apply force parallel to the ramp so that the largest component of your force is actually pushing the box up the ramp, okay? Well, since we know about projections, we can actually figure out, suppose that your force has a magnitude of, suppose you're putting, I don't know, 50 pounds of pressure on that box. Okay, well then your vector has this component form, right? If we're looking at a force vector, 50 pounds in the x direction and nothing in the y direction, we could calculate how much of this 50 pounds of horizontal force is actually helping this box move up the ramp by doing this projection, right? If we take the vector of the ramp and we start it at the same point that we have the vector of your force, and then we project 90 degrees onto the vector of the ramp, and we look at, this is like that shadow projection vector, right? This is how much of your 50-pound force is actually helping the box move up the ramp. Okay, so if we could figure out the magnitude of this vector, we would figure out exactly how much of your 50 pounds is helping this box move up the ramp, because the rest of that 50-pound force that you're exerting is actually moving perpendicular to the ramp, which is increasing friction, making it actually harder to push that box up. Okay, so projections of vectors is very important in physics for classical mechanics. It's very important for calculating force and work and things of that nature. So yeah, I hope that helps with the concept of understanding what the projection of a vector is. And in this next video, we'll just do a couple examples of how to use the formula to actually figure out the component form of these projection vectors.